The A train goes 12 miles per hour slower than the E train. The A train travels 230 miles in the same time that the E train travels 290 miles. Find the speed of each train. Do you guys remember the little organizational device I gave you for these problems? What did we set up? A little tic-tac-toe chart. Yeah. It's kind of a gimmick, but it's a good gimmick. It helps you organize your information. On the top of each column, I put one letter from the formula. Distance equals rate times time. I'm going to label the top two rows that go across. Well, one of them is just going to have to do with information involving the A train. And so that's the first row going across. The second row is going to involve the E train. And the idea is to use this, it's a table really, right? Tic-tac-toe chart or table. The idea is to use this table to organize what you know and what you don't know so that you can set up perhaps a system of equations that you can use to solve this problem. And then that system is going to turn into one rational equation, which is why we're including it in this section or in this chapter. So let's see. Do we know how far the A train travels? 230 miles. So let's fill that in right here. How far does the E train go? The same amount of time, which we're not given, the E train goes 290. So it's the same time, so I don't know what the time is for both, but couldn't I label them with the same unknown, t? You want as few unknowns as possible. Okay, now what about the rate? Let's see, the A train travels 12 miles per hour slower. First sentence, right? Then the E train. So, okay, the A train's rate is being compared to the E train's rate. So we're going to call the rate R, but the rate of which one? Little r. Yeah, since you're comparing the A train's rate to the E train's, you're going to want R to stand for the rate of the E train because that's what you're comparing the other one to. So R equals the speed or rate of the E train. And it's always nice to put down units. I mean, here I didn't do it. We know it's in miles, though, right? It's not a bad idea to put down units. At least if you don't put them down in the chart, I don't blame you, but at least write down your units at the end of the problem, right? Oh, so the rate would be in miles per hour. I know that just from looking at this. Okay, so if I call the rate of the E train R, fill that in the chart, can I come up with the rate of the A train? So yeah, the A train goes 12 miles per hour slower than the E train, so it's just R minus 12. And it does get a little bit messy if in the chart you put in the units of measure, so you don't have to do that if you don't want to. So, okay. Any issues with the chart? All right. Let me show you how to get a single equation. So there's two equations here, right? There's 230 equals R minus 12 times T. Would you agree with that statement? So where did I get that? Just from the top row, right? Distance equals rate times time from the top row. What's the second equation? Yep, 290 equals R times T. But here's the thing. I don't care about T. I want R. And so when that happens, you should solve for the variable you don't care about. And then use substitution to get R, because when you substitute, you're going to have everything in terms of R if you solve it for T. So the idea is this. If I solve this guy for T, what do I get? The operation here is multiplication. What could I do to both sides? Divide both sides by R minus 12 and get 230 divided by R minus 12. But instead of plugging that in right here, I'm going to solve this one for t as well. So take a look at this equation. I've got r times t on the right. If I want to get t by itself, what do I do to both sides? Divide by r, and then I get what? 290 divided by r. So then what I can do is I can set both of those guys, since they're both equal to t, I could set both of them equal to each other, right? Sometimes I do it within the chart itself. Okay, so I'm going to set those guys equal to each other. Let me finish a thought here. I'm having trouble finishing a thought today. Okay, so that equation is good. We can solve that, and we're good to go. Sometimes I actually do that ahead of time in the chart. So you know that if distance equals rate times time, and you solve for t, you know that t is equal to what? If you solve this formula for t, t is equal to what? Distance divided by rate. So I could have got this equation, or the elements of this equation, from the chart and just said, oh, distance divided by rate, oh, in the first row, that's 230 divided by r minus 12. In the second row, that's 290 divided by r. Sometimes I put it in the chart, and then I just set the two guys that are equal to t equal to each other. Either way, it doesn't matter, does it? If you come up with that equation either way, it's going to work. It's a single fraction on both sides, right? So what could you do to solve this? Cross multiply. So 230r equals what? Actually, I'll put that on the right side. 230r on the right side, and then what do you have on the left side? 290 times r minus 12. Okay? 290 times r minus 12 is equal to 230r. All right, what do you got to do to solve this equation? Distribute the 290. Okay, I can do that. Boom, boom. Well, help me out here. What's okay, I'll do the first multiplication for you. 290 times r is 290r. Wasn't that nice of me? 3480. So 290 distributed over a minus 12, I'm hearing 3480. Did I get that right? Okay. And then equals 230r. Any questions on that? Okay. It's just a linear equation, isn't it? So how do we solve a linear equation? In other words, you don't see like an r squared, do you? Or an r cubed. So it's not like we're going to set everything equal to 0. We're going to get the unknown on one side and the constant on the other side, and then we're done. We solved it, right? So, okay, so what could I do? Subtract 230r. Easy enough. And then maybe add the 3480. So what does that give me? 290r minus 230? 60r equals 3480. Help me out, those of you with a calculator. Divide both sides by 60. What do you get for r? 58? 58 what? mph. So how would you summarize your answer? You go back and read what they're looking for. They want the speed of both trains. So I could write something like this. How do I know which one's which? Well, that's why I label things carefully, right? Oh, r is the rate of the E train. So if you forget, you can look back. You could say the E train goes 58 mph, and the A train goes 12 miles per hour less, so 46 mph. Does everybody see where the 46 comes from? Okay.